holes coming together, coalescing, and then settling down to a bigger black hole. The agreement, you see, between the blue and the red of theory and experiment is incredible and can be used to infer, to deduce, that these black holes weighed roughly 50 times the mass of the sun, that when they came together, the power that was released was 100 times greater than all the stars in the universe. Only for a fraction of a second, however. But the total energy released was equal to the total annihilation of a star whose mass is 3 times the mass of our sun. That energy was released in a wave of gravity, like throwing a stone in the water, which spread throughout the universe, and 1.3 billion years later hit the Earth and was recorded in these observatories. This is amazing that a smart monkey could do this. It is an incredible achievement, in my opinion, of humanity.
Yes, it is.
In the last 100 years, we've understood an immense amount about the universe. Way almost back to when it began with something we call the Big Bang, because we don't know what it is. But our understanding of the 13.7 billion years of the universe that we can observe from almost the beginning until now, and the formation of structure, and the expansion, and the accelerated expansion, is remarkable. What is that good for? Probably nothing, except to answer the questions that your children will ask you. What is the universe? Where did we come from? Where are we going? We must know, even if we have better ways now of navigating ships. We don't need the stars. And now we're beginning to ask, what is the Big Bang? This has now become a question not for religion or philosophy, but for science. How did the universe begin? This is now, in my opinion, a well-formulated scientific question. We're trying to probe farther and farther back, probably using gravity waves. And maybe we can ask, we can certainly ask, and maybe we can answer for one of you young people, or the next generation, what was the beginning? Now, I want to turn now to a different subject, which was the motivation for my coming here, where I met Placido in the ICTP in Trieste, which is a very interesting place. It's where the Abdus Salam International Center for Theoretical Physics is. Abdus Salam was a great Pakistani theoretical physicist who won the Nobel Prize for his theory, his contribution to the theory of the weak nuclear force. That's the force that is responsible for radioactivity. And Abdus Salam, coming from a developing country, decided, before he got the Nobel Prize, early in his career, that he wanted to do something for his country and for what used to be called the Third World, now the developing world. And he created this international center for theoretical physics. And he expressed better than anyone else the importance of basic science for developing countries. He said, "It is impossible to talk only of technology transfer. One should talk of science transfer first and technology transfer later." He believed that unless a country is very good at science, they'll never be good at technology. At best, they'll be consumers, and most likely they will be poor, uninformed consumers. Not only that, and perhaps more importantly, Salam believed that scientific thought is not a luxury. It satisfies our deepest curiosity. It is the common heritage of all of mankind. And his institute was an attempt to provide equal opportunities to scientists, to young people from all around the world, so that they can engage in the creation of new physics and new science for the benefit of all. Now, there had been institutes of theoretical physics before. The Niels Bohr Institute in Copenhagen, created by Bohr, was a center where quantum mechanics was developed in the early part of the century. The Institute for Advanced Study at Princeton was a refuge for European scientists fleeing the Nazis and became a great center of physics and other sciences. But the ICTP was specially constructed to help encourage the fostering of science and technology, but first science, to people, scientists, researchers who came to Trieste, received training, went back, and it has been flourishing for the last 50 years. Now, if you were going to do this, why would you choose theory? Salam chose theory because he was a theorist, but more than that. And I truly believe that in the development of science in countries that are yet developing, theory can play a special role. Theorists, unlike their public image, are not loners. They're not crazy people in white jackets and hiding or alone in the laboratory. They're intellectual extroverts, even if they're social introverts. They continually crave engagement with other theorists. It's true of mathematicians as well. They collaborate in joint projects in groups of 1, 2, or 3 or more colleagues. And they share their ideas very freely. They expose their ideas to constructive suggestions, criticism. Theoretical physics is an intensely cooperative effort. And they flourish on face-to-face interaction. And theory institutes play a very important role in advancing science, especially sciences, theoretical sciences, physics, chemistry, and now biology. Now, we all know that the division of science into different disciplines, physics, chemistry, biology, geology, is totally artificial. There's nothing in nature that has a dividing line. When you discover a new phenomena, it doesn't say chemistry on it. It doesn't have labels. These disciplines are created by history and by tradition and by bureaucracy and often hinder the development of science. Especially nowadays, but this has always been true, really, that the most exciting developments often are at the boundaries of these artificial, traditional fields. And therefore, they require the efforts of many different kinds of scientists. People, administrators, bureaucrats try to solve this problem by creating interdisciplinary departments of new bureaucracy. It doesn't work necessarily. But I found that theory, modeling, looking for universal features, which are characteristics of theory, serve often as a glue for such interdisciplinary efforts. Now, Salam's Institute has been enormously successful and imitated around the world, which is the sincerest form of flattery. And one of the first imitators was the institute where I now am, although I wasn't back in 1979 when it was founded in Santa Barbara. This is our institute. Now it's called the Kavli Institute for Theoretical Physics. It is similar in some ways to the ICTP, but its model is not to its direct mission is not to foster development in the developing world, but rather to foster the advancement of physics. Although we interpret physics, I interpret physics as everything that physicists do. And physicists do everything from cosmology and astronomy to material science, condensed matter, molecular and atomic, elementary particles, and biology, which is what I call the physics of living matter. Our institute is an international center where people from around the world propose programs which we help develop. They come and spend months at the institute in groups from 50 to 150 over 3 months, working on frontier areas. We run 12 such programs a year. We have over 1,000 visitors a year. And there are many other such institutes. In mathematics, there are many. MESCYT, AIM, these are all institutes in the United States and in Europe, and the Newton Institute in Cambridge, which is mathematics and physics. As the years have developed, there are more and more attempts to construct such institutes, given their success. The Institute for Nuclear Theory in Seattle, the Galileo Institute for Theoretical Physics in Florence, the Perimeter Institute in Canada, the Max Planck Institute in Dresden. And I myself have been involved in trying to create models like this throughout the world. In China, we have the Kavli Institute for Theoretical Physics / China, which is an imitation of the Santa Barbara Institute. And recently, just last year, we inaugurated the campus of the International Center for Theoretical Sciences in Bangalore, India. ICTP, in the last 10 years, under its current director, Fernando Quevedo, who comes from this part of the world, has reached out from Trieste to help foster, found, and guide institutes, similar type institutes throughout the developing world. And there are already 4 that that are underway. The first is the ICTP South American Institute for Fundamental Research at the University of Sao Paulo in Brazil, which I've also been slightly involved with. The Mesoamerican Center for Theoretical Physics in Chiapas, in Mexico, which began, I think, 2 years ago. 2 more that are beginning. One, the ICTP Eurasian Center for Advanced Research in Izmir, in Turkey, which has, I think, is in its initial stages of functioning, and one which hasn't yet opened but will shortly in Africa, the East African Institute of Fundamental Research, the University of Rwanda. All of these are based on the model of the many examples I gave you, ICTP and KITP, of focusing on excellence and on interactivity, bringing people together for education and research, programs, lectures, pedagogical courses, conferences, serving as a regional or international center for research. In all of these examples that I've been able to find, I noticed that there's a part of the world, the Caribbean, and there's nothing here. So I'll leave you with a question. Where will the Institute for Theoretical Physics in the Caribbean be? Thank you.